So my name is Matt Steele. I am one of the research services librarian here at the university. I'm joined by Jeff Worst, and we are going to be showing you how to do some data cleaning with R, specifically using the Tidyverse package. If you have any questions while this is going on, as I mentioned before, you can feel free to unmute and ask me. What I mainly want for this session is for you guys to get some hands-on work using R, specifically on data cleaning that you can take back and practice on your own. So I do not want people to fall behind. So if there's anything that I can clarify, feel free to ask me to clarify. You can also message Jeff using chat or ask a question in the chat, and we can get to it that way as well. As we will be working on, if you came to the first session, this is going to be a little bit more hands-on where you're going to be, the first session was really important to get you to understand the fundamental concepts. This will be more of an application of the concepts that we are going to be using. So there will be downtime in between me talking if you want to wait and ask a question as well. So that'll be a good time to ask a question. So again, my name is Matt Steele. I will be sending off these slides and we will have a recording of this that I will send off. But if you want to contact me, you can search Matt Steele WVU on Google and you get to this lovely page. Just so happy with this picture still. I haven't asked them to change it for unknown reasons. But easy ways to get a hold of me if you have any questions about working on any of your data projects, especially if you're working in R, feel free to email me and I can get back to you pretty soon if you want to talk about it. We also have a very easy to use appointment page that you can see all my available times, where if you want to set up a meeting, we can meet over Zoom and kind of talk about what you are working on. This week, we're going to be doing data cleaning. Next week, if you haven't signed up for it yet, we're going to be doing data visualization and presentation. So what do you do with the finished product of a clean data set? How do you do visualizations, plots, and graphs? Or how do you use that data to create an article within RStudio itself? We also have additional data services workshops. We mentioned tomorrow we are going to be having a introduction to Python, which is a different type of programming language. I personally am a bigger fan of R, but we will be doing a Python one. Also, if you're interested in things like GitHub, so GitHub is a repository to store your data-focused projects, either for data analysis or whatever you're working on. If you are interested in learning how to use GitHub, we are going to be having one on next Thursday for that. But you can see all the data services website, oh my goodness, data services workshops that we are working on with that link. Today, we're going to give you an introduction to the Tidyverse package. It is an add-on package for R that gives users a bunch of functions, built-in functions to clean, transform your data sets. We're going to do that by showing you how to load data with Tidyverse and then how to perform operations with multiple functions. So if you are doing a cleaning, you are running an operation and you can link together multiple functions to run that task you are trying to perform. We're going to then go into what are some of the cleaning data functions available to you and how to run them. And then we're going to end by talking about how do you export the data that once you've sat down and cleaned up your data set, how do you export that clean data? We're also going to look a little bit about exploring the data and how to get things like descriptive statistics, basic descriptive statistics. If you want to get into further analysis of it, like something like an ANOVA, you would have to do a separate package for that, but we'll just look at your basic descriptive statistics with it and how you explore the data set that you are looking at. As I mentioned in the first session, but if you are new to this session, it is really important when using something like R, a programming language in particular, that doesn't always write down, here are the necessary steps. There's no GUI menus, for instance, that allow you to know how you run a particular operation. Documentation for packages or for base R becomes really important. Tidyverse itself has a really great documentation system within it. So we're going to be working a lot in dplyr. If you want to know all the functions that are available to you in dplyr, you can go to their website on their reference page, and you can get an overview of all the various functions available to you, and then how to use them. So what the function does, what arguments you can put into it, and some examples of how you use it. Another strong suggestion I would have, R is an iterative learning process. It is not something you master in an hour and a half. It's something that you learn and then you practice on it either on your own work or by doing exercises. We have a really great database through the library that is called the O'Reilly Learning Platform. Contrary to your databases you might be used to, where you use it to go look up scholarship, this is a database that will actually teach you how to teach you soft skills and things. And some of these soft skills might be, how do I use R? Some suggestions I would have are the R for Data Science second edition book. It is an easy read. It will go over a lot of the stuff we talk about today and has built-in exercises for doing it. It is written by Haley Wickham, who is one of the chief architects for Tidyverse. So this is written by the person who built the system. So really high suggestion. I would also, if you are more of a visual learner, our programming for statistics and data science is a great little course they have in there. It's about 13 hours, but it is broken up into about 10-minute chunks. So if you just want to learn long term, you can kind of go through that. Well, that is a good question. Advantages of R over something like GraphPad, Origin, or SPSS. I can only speak to SPSS. It is the only one of those three that I've used. All the SPSS is a proprietary software, which means you have to have a license to use it, which is $90 usually a month. Not cheap, even for a student. R is free and open source. Now, what you are paying for with things like SPSS are a GUI interface. It is very easy to use. It is like using Microsoft Excel. It's a slightly higher threshold than Microsoft Excel, right? But you are going in there, you're taking your mouse, you are clicking on menus, you are saying, oh, this is how I run an ANOVA test. So you go into the menu and it has a listing for ANOVA test. R is probably more versatile because you have a greater array of things that you can do within it. Because you're coding, you have much more options of what you can do and how much control you have over the actual analysis. It is also in difference to SPSS, it is non-proprietary. So you can export your finished products pretty much into any format, even these proprietary ones. We'll talk about, you can export into an SPSS. And as journals and other I'm blanking on the word, other consortiums or other repositories are asking for more and more. How did you do something? Reproducibility. We want to see the steps, right? When you are in SPSS, you are literally clicking a mouse around and these clicks are not saved. It does not have written out for you. These are the steps that you have. As you look through an R code for somebody that did a data analysis project, you can see every step that they did along the way. And you could, if you have R, and you could take their code and rerun it yourself. So it has more reproducibility than these other ones. It is also lighter on your computer, so you don't have to go to the lab. You can use your own personal computer to run it. Where I know on my work computer, when I opened up SPSS, my computer would slow down to a chug and it'd be about a 10-minute load up. So those are some of the advantages to using it. Just to recap, and if you weren't here for last week, just to recap some things that we did talk about that are important to this week. Within R, you have functions. You can either create your own function, which we won't get into, or you can use the built-in functions that are available to you. When you download R and when you load up R at any time, you have a bunch of functions available to you in what is called base R. That is, the base version of it that you downloaded. You can, however, then add on packages to R. Because it's open source, people can build their own packages that have their own functions within it. Functions now are what gives you the commands to do something. So my analogy is always the functions available to you are like looking through a toolbox, and you see that there's a hammer in there. A hammer will allow you to hammer a nail in. You see there's a screwdriver in there. A screwdriver will allow you to screw a screw in. Think of those functions as the same way. Hammer is the function. I need to nail something, I grab my function. I grab my hammer. Arguments are how the function performs. Now, arguments change based on the type of function you are using. You'll have to put different parameters in based on what you are asking it to do. But you can think of it, if you take back to the hammer analogy, what angle do I want the hammer to go at? I want it at a 90-degree angle. I want it at a 45-degree angle, something like that. I want this much velocity into it. Objects are ways that you can store information into an easily retrievable line of code. So think of objects kind of as a file drawer that you can put information into. This information can be a number, it could be a operation, it could be a data set. A lot of the times what we'll be doing is when we load up our data, we'll put them into an object so we can easily call that data set at any point or work on that data set at any point. And then one thing that is really important is as we type in code into our script, nothing runs until we say it. So you always, if you want to save something, you always have to run that line of code. Okay, so let's get started. And on your own computer, go ahead and open up RStudio. Once you have RStudio loaded up, we are going to start a new file. So we are going to be working on our script files today. So just go ahead and go into File, New File, RScript. While you are doing this, some things that I'll just note really quickly. If you did not attend our first session, one thing that I would suggest that you do is go into Tools, go into Global Options, and in your Code tab, I would really suggest highlighting soft wrap R source files. What that allows it to do is, if you don't have that clicked, it'll keep going horizontally indefinitely until you hit enter with your code. Soft wrap will get to the end, like this area here, and it will wrap it down to the next line. Just easier way to see your code. And then if you also want to, I prefer the native pipe operator. We're going to be using the pipe operator today, but you can go ahead and click that as well. And so I'll let you guys get started on getting your file open. Once you get it open and you're ready to move on, go ahead and raise your hand in chat so I can just get an idea that most people are ready to move on. Okay, thank you. So again, we're just opening up RStudio right now, and we're starting a new script file. And to do that, we go into File, New File, RScript. And I can kind of just talk while we're doing this. You can see in RStudio, you can do several different types of file types. RScript is the main one. But RStudio is not limited to our language. So you can see that you could run files with all these various ones. All right, looks like most people have gotten this done. So let's go ahead and get started. The next thing I want you to do is set the working directory. So if we remember from last class, or if you're new to this class, your working directory is essentially telling the computer, this is the folder that I am working on. This is where I'm at on my computer right now, and these are the files I want to access. So when we talk about things like a working directory, this is essentially just the folder I'm working out of. So every time you start an R session, starting an R session means R had been closed down and you opened it back up, or in the session you either restart or quit a session and start a new session. That is considering starting a session. Anytime you start a new session, you will need to set the working directory to the folder that you are working in. To do that, we go into Set Working Directory under Session. So we're going to go to File, Session, Set Working Directory, Choose Directory. Once you have that, then you are just going to access the file folder that you downloaded for this class today. So the file folder that we downloaded through GitHub, we're going to be accessing now. So if you remember where you put that on your computer, mine, for instance, is in our projects and cleaning data online. And then you just click on the Open button, and you should get a note in your console that says Set WD, and then a file pathway for it. You can double check that you have actually done it. If you look in your Files tab, you should see a very similar set of files that I have for you guys. So go ahead, set your working directory. I'll go through it one more time. Session, set working directory, choose directory, and then find it using your File Explorer. And while you guys do that, let me do the zoom in. And then when you are done with that, just go ahead and raise your hand again. The working directory is also when you start exporting files, it is where the files will be exported to. Okay, looks like most people are done. You can go ahead and lower your hands and we will continue working. So today we are going to specifically be working with a package that is called Tidyverse. And Tidyverse is actually a suite of packages. So it is a package you can download that has multiple packages built into it. And because R is open source, people can build these add-on packages that allow you to use their functions within it. If uh, if you are wondering, R has a consortium of people that work on. They have what is called the Comprehensive R Network. And one thing, if you are worried about add-on packages, that anybody could build them, and how do I know that doesn't have malicious software some way built into it? One thing you can do is you can go into CRAN and you can go into their available packages. These packages, to get on this page, it has to be vetted by CRAN. So these are vetted packages. So the consortium also does things like say, hey, you made this package. Is it working? Does it actually have malicious content within it? Or does it not have it? So if you are worried about the packages within that, you can always check if a package is on CRAN or not. The one we are going to be looking at today is called Tidyverse. With using packages, if you have not installed a package before, you do have to run the line of code that says install packages, the function install packages, and the name of the package in quotation marks. No, you should be using the one that is called our cleaning data online, Aaron. The one that was downloaded from today, from 9/13. Yeah. So if you go with the one that, if you just do the GitHub with the link that Jeff put in there today, you should be able to do it. Anybody else too, if you're looking at the first steps, we want to be in the R cleaning data. Okay. So installing packages, you only have to install a package one time. So if you do not have Tidyverse installed onto your computer, you will need to run this line of code one time. And when I mentioned, so right now I've typed in this install package, but I've not run this line of code. So nothing has changed in my environment or anything. Right now, Tidyverse is not installed. To run a line of package, you need to click on the run button up here in RStudio, or if you are on a PC, you can hit Control Enter for the keyboard shortcut, or if you are on a Mac, you can hit Command Return to run the line of code. But you do need to run the line of code at least one time if you have not installed it. If you have installed it, every session that you want to load a package or you want to use the functions in that package, you do have to load the package up. And you do that with the function library and the name of the package you want to load up. So, and you might be thinking, well, why do I have to load up a package every time? And this is basically because R, to save your computer's memory and the amount of processing that it has to do. When you quit a session, which you quit a session by exiting RStudio or physically going into the session and clicking on quit session, it unloads all the packages that you've loaded up. So those packages aren't running in the background of your computer. They're not taking up processing power. They're only running when you need them to be running. So every time you start a new session, you do need to run the line of code with the library. And if you look at other people's codes for projects, usually what you'll see at the top of their page is the working directory that they're working out of line of code. So they can just run that line of code and easily set the working directory, and then any libraries that they may be running. All right. So let's go ahead and load up Tidyverse. If you haven't installed it yet, install it with the install packages command. And if you do have it installed, if you were at the last session and you installed it, you'll just need to run the library Tidyverse. So I'm going to go ahead and run that line of code now. You'll notice that it loads up if you get this message in your console area. I've unloaded these packages and we have these conflicts. So let's go ahead and let's load up Tidyverse. If you have any questions, feel free to ask. When you have loaded up Tidyverse, go ahead and raise your hand. All right. Looks like most people are doing it, so you can go ahead and lower your hands. So as I mentioned, Tidyverse is not actually just one package. It's a suite of packages that all work together and are all focused on data science and data analysis principles. So Tibble will create lighter data frames. TidyR allows you to rearrange your data or tidy it up. Reader allows for better importation of the data that's lighter on your computer. ggplot is your data visualization. If you come to next week's, we're going to be working extensively with ggplot. dplyr is the one we'll use mostly today. It is a data manipulation tools that you have for you. Lubridate, if you've ever worked with any data focused program, uh, for some reason they all kind of struggle with dates, and R is no exception. But Tidyverse has a great package that is called Lubridate that makes it really easy to work with dates. Per is if you are working with functioning programming. We won't get into per today, but it is a good one. There's another one that I don't have listed, Stringer, if you are looking up strings. Forecats, if you are working with categorical variables, allows you to easily clean those up. And if you are working with data from proprietary statistical packages, your SPSS, your SAS, your Stata, so on, you can actually read and export data from those proprietary with the Haven package. So first thing we are going to do, and this is important that you have your working directory set with the cleaning data, is we are going to load data with the reader package. So within R, base R, it has a function that is, let me go back really quickly and just talk about one thing really quick. In your message for that you loaded up Tidyverse, you're going to get, hey, these are all the packages we loaded up. But then you also probably got this listing of conflicts that you have. Functions do a particular command in R. So there's only so many things that we can name functions that accurately describe them. So what this conflicts is saying is, we'll do this first line. Right now, a package we loaded up, dplyr, has a function that is called filter. Right now, that filter is going to overwrite one that was already in base R that was also called filter. Now, we can specifically target package functions within R by doing the name of the package, colon, and the name of the function we want to run. The name of the package, colon, just as you are kind of working on things and working through R, is also a way that you can see in that package what functions are available to you. So this is just another way that you can also see, okay, I'm running the dplyr package. What do I have available to me? All right, so in base R, they have a read.csv for reading data into your program. The problem with read.csv is it tends to be a bit clunky. I mean, it's actually very clunky, and it's a heavy load on your computer. So Tidyverse provides a function that does the same thing, but it's read_CSV. They also have read_delimited if you're not using a CSV file. Our I forget what the other one is. I think delimited and CSV are the main two to use. So we're going to do read_CSV. So the first thing we're going to do is we're going to create a new object that we want to save this data into. We're going to call it SW_DF, Star Wars _data frame, essentially is what I'm calling this. We're going to do the function read_CSV. And then in parentheses, we're going to choose the file name that we are going to use. So we are going to be loading up the Star Wars data frame that we have down here. So if I start typing in star and I hit tab, or S and I hit tab, it will auto-suggest some files that we have in our current working directory. So I'm just going to choose starwars.csv, and then I'm going to run that line of code. Once I do, up in my global environment, you'll see that a data set is loaded into the object SW_DF. It is a data set that has 87 observations or rows on 12 variables or columns. So go ahead, create a new object called SW_DF, and then using the read_CSV, load the starwars.csv file into that object. If you have any questions, feel free to ask. And when you are done, go ahead and raise your hand. Okay, looks like most people have gotten that loaded up. You can go ahead and lower your hands. To call an object at any point, you just type in the name of the object and click the run line. That'll bring up our data set. It'll give you just a basic view of the data set, so not the full data set. What we're getting is basically the head of it, but you can see we'll get these variables, what type of data type they are, and then the first 10 observations within it. And then if there are more rows or more variables, you can see what other variables and the data types that they have in it. I'm not going to actually demonstrate this, but just for your knowledge, and again, this is where something like going through the documentation is very helpful. There may be instances, there will probably be instances where you are working with somebody who uses SPSS or uses SAS, and you are working together on the same data set. The Haven package, uh, the Haven package allows you to run these allows you to load up these. So you'll have things like read SAS for SAS files, read SAV for SPSS files, read DTA for STATA files. It also allows you to read Excel files into it as well. So if you are working with somebody that is using an Excel file, you still can read it. So even if it is not in an SPSS format, you can still read these files into R and work on the files on your own computer. Some things too you might want to do is explore the data. So some ones that I typically will use, the view function will allow you to view the entire data frame within its own tab. So as I mentioned, when you just call the object in R, you're just going to get the head of so enough to fit on the screen. If you want to see the whole data frame, you can do the view function to view it. You can also, a lot of the times, I need to know what are the column names for it. So you can get the column names with the call names function. And then if you want to see the structure of it, you can either do the base R, str function. So um, within each variable, what types of variables are they? How many observations do they have in each variable? And then again, what types of variables they are, what data types. I kind of prefer if you are using Tidyverse, they do a similar thing, but they call it the glimpse function. That is just a little bit cleaner of a way to see what is going on in the data frame. You can also get things like summaries, descriptive statistics then of what is going on in the data frame. So if you want to get a full view of the data frame, you can do the summary function, and anytime they have uh, a numeric variable, you can get the min, first quarter, median, third quarter, max. And you can also select specific variables to get it. So if I wanted to grab the mean of the height variable within the Star Wars data frame, so this guy right here, I can go ahead and get that. And the average height within this for a character is about 173 inches. Same thing, you can grab median, standard deviation, min, max, and sum. And now this is a big thing when you start to work on cleaning a data set because a lot of the time you might need to a lot of the time you might need to string multiple functions together into one operation. So an operation being all of the functions that run onto this particular one. To use this, we use something that is called the pipe operator. And a pipe operator could either look like this, an iron bar with a greater than sign, or it can look like percentage signs and a greater than in the middle of it. So if you see either one of them, they are the pipe operator. It's just whether or not you've selected to use the native pipe operator. If you didn't, you're going to get this percent sign. You can either put in you can either do iron bar greater than or do the percentage greater than percentage. I find it much easier though to use the keyboard shortcut to put in the pipe operator. For PC, it is Control Shift M. For Mac, it is Command Shift M. They are really saves you a lot of time to put them in. And what the pipe operator will essentially do is it'll create, think of it as like a pipe system, right? And so function one will go into pipe operator function two. And so function two, function one, and it will all flow into what the data set that you are working on. And this will make more sense as I show you it. So if we are looking at the Star Wars data frame that we just loaded up, let's say, and don't worry about what these functions are doing right now. We are going to talk about them in a little bit. But let's say we want to first off filter the home world. So we are only seeing characters from Tatooine. Then we want to only select the name, height, mass, and species variables that are available to you. And then we're going to relocate the mass variable so it comes before the name variable within the set. We can do these with pipe operators. So I'm going to just go ahead and copy this, save us some time. So what this line of code is saying, run all these operations on run all these operations on the Star Wars _ data frame data set that we have. So the first thing we put in is the object we want to work on, which is the Star Wars data frame. We then put a pipe operator next. Next will come the first operation, filter homeworld to only equal Tatooine. Then will come the second operation, select these variables, and then will come the third operation, relocate this. If I go ahead and run this line of code, it filtered out and then selected these particular ones. Now, this is where R becomes very important. R is very order centric. So the order of operations matter. So if I change this around even a little bit, if I just put select before here, this is now saying run all these operations on the Star Wars _ data frame data object. First, select only the variables name, height, mass, species. Then filter the variable homeworld to only equal Tatooine, and then relocate it to relocate math before name. So if I run this, I'm going to get an error, and it's going to say the object homeworld is not found. Does anybody have any idea why the object homeworld is not found, or the variable homeworld is no longer found? So it is not being found because the first operation we ran limited our data set. We only selected the variables mass, height, name, and species. So the variable homeworld that we were trying to filter in the second operation was thrown out. So because this operation happened first and because order matters within R, this right here, this homeworld variable is no longer a part of what we are doing. So it can't find the homeworld variable because it doesn't exist anymore because the first order of operation threw it out. Does that make sense to people? It is one of those that sometimes is a little, it's easy once you understand it, but getting your head around it the first time can sometimes be a challenge. Okay. There's no questions, and we're going to get to doing stuff that you guys will actually be able to get some hands-on experience with. We're going to try and run all these various functions that are available to you through Tidyverse. So filter allows you to filter out observations based on available criteria. Select allows you to retain or filter out variables within your data set. So if you either want to keep certain variables or throw certain variables out, you can. Arrange will allow you to sort a variable. Mutate is a big one. Mutate is the one that I use probably most often. This allows you to change variables observations or create new variables and observations based on the observations of another variable. So this essentially lets you use the observations within a data frame and create brand new ones or change around or recode a current variable in it. So if you're doing things like recoding, you'll be using the mutate. Group by allows you to take a categorical variable, group each one of their observations into bins, and then run some descriptive statistics on those observations. Summarize works with group by. It's what allows you to actually get the descriptive statistic. Relocate changes the position of variables within a data frame. Rename changes the name of a variable. And then working with missing data, you have a drop NA, which will drop all missing values from a data frame, and replace NA, which allows you to replace the missing variables. So the first one we are going to work on is the filter. So if I look at my SWDF, we have a we have a variable that is called hair color. And within it, you can start to see all these various hair colors, and we do have some missing data within it. So what we are going to do here is we are going to limit the observations within the hair color. We're going to only filter it to blonde-haired characters. So to do that, we're going to first create a new object. Now, this is important. Whenever you are creating objects within R, it will overwrite. If you name an object the same as one that you already have in your environment, it will overwrite that object. So one thing that I really highly suggest as a beginner using R is that you try and stay away from naming objects the same thing if you are doing some major changes to it. So filtering out everything but blonde hair, I would say would be a major change to it. So I'm going to just create a new object. I'm going to call it Star Wars underscore data frame underscore hair. The other thing is when you're naming objects and you are running something, make it as descriptive as possible for yourself. So if you see an object that is called hair, you can remember, oh, that's where I was filtering out the hair variable. So the first thing we're going to do is we're going to put in the data frame that we are going to work on. So we are working on the Star Wars underscore DF is the data frame we are working on. Then we are going to put in the pipe operator. Then we are going to run our function filter. And then we are going to say the variable that we are filtering. So I'm going to filter the hair color. If you notice, as I start to type things in, RStudio is giving me some suggestions based on the data frame that they're looking at. They know we're working on the Star Wars data frame. And then once I start typing in hair, they're saying, hey, within this, you have a variable called hair color. Is that what you want to use? So you can go ahead and choose that. And then we're going to equal blonde. Within filter, we are going to be using Boolean operators. So you can have your observation equal, so it has to be equal to something by using the equal sign. Exclamation equal is not equal. So if we wanted to do everything but blonde, we could do the not equal. Less than sign is less than, greater than sign is greater than, and then less than or equal is less than or equal, and greater than equal is greater than or equal. So the other thing is R is very much case dependent. So blonde with a capital B does not equal blonde with a lowercase b. They are two different entities according to RStudio. So if I put capital B blonde there, I would not get any returns because they wouldn't find any capital B blonde. So pay attention to what's going on within your observations as you do this as well. But if I go ahead and run this line of code now, and then I call the object SW hair, and I run that, we are only getting characters with blonde hair. So go ahead and on your computer, try and run the filter. You can do it with the hair color if you want to. If you want to look at another variable, that is fine as well with me. Or if you want to try out some of the other Boolean operators, the not equal. We are using a character, we are using a character variable right now or a string variable. So equal, not equal are going to be the ones you are using. However, if you use it in numeric variables, so if we took a look at the height variable, then you could also use the less than or equal then for it. So uh, go ahead and take a look. And if you have any questions, please let me know. And raise your hand when you're ready to move along. Okay, looks like most people are ready to move along, so you can go ahead and lower your hand. So you can also string multiple variables together with the and or. And is the ampersand, or is the iron bar. So I'm just going to show this one, but if I want to say, hey, I want to have everybody whose hair color is not blonde and whose height is, let's say, greater than 50. Oh, that's right, 100. We could also run that. So you can see here in the height, nobody's going over 100 for what we see. So this is just a way that to put multiple criterias on it. And again, just showing you that you can do it then also with numeric numbers. So filter allows you to say, hey, within this variable, I want to see only these observations within it, and then build your criteria from there. Um, a similar one, but or not a similar one, but an easy one that you may sometimes have data sets that you don't want particular variables within there, or you want to throw them out for any reason, is to use the select function. So the select function allows you to keep or remove particular variables from it. To keep, particular variables. So we're going to do the SW select and then the assignment operator. Just a reminder, assignment operator is how we create objects, and it is the alt minus sign on PC, and it is the option minus sign, I believe, on Mac. So again, then we're going to be working on the Star Wars underscore data frame data set, and then we're going to put a pipe operator in there and the select function. And let's just say, let's just keep character ID and height. So if I go ahead and run that, and then I look at the SW select object, now we have a data frame that only has the character ID and their height within it. You could also say the opposite. You can say, hey, I want to keep everything but remove these particular variables with the minus sign. So again, this is also a reminder that if I name an object the same thing, but I run a new operation on it, it will overwrite the current operation. So since I ran that operation, the SW select that we just did is now overridden. And we now have 87 observations on 10 variables because I removed character ID and height. So if I look through there, they are no longer in there. So you can go ahead and try out select. Again, you can try it out with the variables I showed, or you could grab your own variables as well with those. And when you are ready to move along, just go ahead and raise your hand. If you have any questions, feel free to ask as well. Okay, looks like we are ready to move on. You can go ahead and lower your hands. All right, so the next one we're going to look at is one of the bigger ones. It is mutate. So mutate allows you to create new variables in your data or change existing variables within it. Mutates observations that are currently within your data frame. And you can do this either by performing calculations or transformations. The first one I'm going to show you is we're going to create a brand new variable. We're going to call that BMI or body mass index. And you get the BMI of somebody by dividing their height by their mass. So right now, if I look in my Star Wars data frame, we currently have a height variable and a mass variable. So if I wanted to use these two observations for each, or these two variables for each observation, I can create a brand new variable. I can call it BMI, and I can use these operations to calculate the BMI for each character or each observation. All right, so we are going to actually overwrite it because we are just going to add a new variable into it. So we're going to call this one Star Wars underscore data frame. So this is going to overwrite the current one. So once we are done, we should have 13 variables in there. We are going to work on the Star Wars underscore data frame that we currently have. We are going to use the mutate function. We're going to create a new variable that is called BMI, and BMI is going to equal the height variable divided by the mass variable. So each one of these, it's going to go through line by line and divide height by mass. And just so we can see it easier when we call it, I'm going to also relocate it. BMI before. So I'm going to put it before the height variable. So if I run this line of code and I look at the Star Wars, you can see already we have 13 variables now, so we have a brand new variable that was created. If I call that, I can see the BMI for each character. So in this one, it took 172 and it divided by 177 and it put it into the observation. So go ahead and try out the mutate function. But if you have any questions, please feel free to know. And when you're ready to move on, please raise your hand. And as you guys are working, let me just mention one thing else. Same with objects. When you use the mutate function, if you create a variable name that is not currently in the data set, it'll create a new variable. If you name a variable something that is already in the data set, so if I named it height for some reason, it will overwrite everything, every observation currently in the height variable. So just be careful when you are naming it. If you are not meaning to overwrite a current variable, make sure it is not the name that you are putting in here is not the name of a current variable. And again, when you're ready to move on, feel free to raise your hand and we can move on. Or if you have any questions, feel free to ask. Okay, let's go ahead and move on. The next one is an easier one. It is a range function. A range allows you to sort a variable. So if we're not even going to create an object with it. I'm going to just say we're working on the SW underscore DF and we're going to arrange. And then I'm going to arrange, let's say, height. So if you just do arrange and then in parentheses, and you can go ahead and lower your hands now. If I do arrange and I do just the name of the variable I want to arrange, it is going to do it by uh, ascending order. So for height, the lowest number is going to be on the bottom. If you want a descending, you have to just put in DEC, DEFC into the description and go ahead and run it. Now it is going to do the largest. If you are working on a character variable or a string variable, it's going to do descending is going to be Z to A. and ascending is going to be A to Z. Okay. Next one we're going to work on is a big one too. It is going to be the group by and summarize functions, or at least things that I typically use when I am doing some data cleaning. The group by function allows you to group together common observations within a data frame and then run in conjunction with the summarize function or run some sort of descriptive statistic on those grouped individual or on those grouped observations. Most commonly, you're going to be using it with a categorical variable. So, for instance, let's keep with our hair color that we just did. If I want to get what the average BMI is for each category within the hair color, we'll create a new object. We'll call it Star Wars underscore group. We'll work on the Star Wars underscore data frame. And then we're going to use the group by function. And then we are going to group by hair color. And then we are going to also run a second function. And we're going to grab the summarize. So we're going to put another pipe operator in there. We're going to name the variable that is summarized. So I'm going to just call this average height. And the average height is going to equal the mean of height. So what this is saying here is run these current operations on the Star Wars data frame that we have, this guy. Group all the observations, all the common observations in the hair color variable. So all the auburns are going to go with all the auburns, and all the blacks are going to go with all the black hair. And then for each one of these observations, create a variable that's called average height. And using the mean function, run the mean on the height for them. So if I run that and I do underscore S or SW underscore, we're going to get a brand new table. So separate from our Star Wars data frame that has grouped. So within the auburns, the average height is about 171. Within black hair, 175. Within blonde hair, 177. So unknown hair tend to be the tallest within it. So group by allows you to group common observations and then get some sort of summary statistics on it. And you can even link these. So you can say things like n equals n, which will grab you the number of observations in each group. And then you could do some, or you could do total height equals some height. So you can get more than one observation on it. So go ahead, try out the group by. If you have any questions, please feel free to ask me. You can do it with hair color. If you see another categorical variable, you can also run it on that. One thing is the descriptive statistics, though, will have to be a numeric or what R refers to as a double. So you would have to run it on something that has a double, but you can choose your own variables if you want to. And if you have any questions, please let me know. And once you're ready to move on, please feel free to raise your hand. Okay, looks like people are ready to move on. So you can go ahead and lower your hands. Those are the big functions that are really available to you through R. The next, well, we will talk about missing data as well. But a lot of the stuff we're going to talk about going forward here is how you use the mutate function to run additional operations. So first one we're going to talk about is recoding data values. So as I mentioned in the first session that we had for this, R will interpret data values on its own within it. But there's going to be times that R is not going to interpret things correctly. Um, Not that they did something incorrect, just that it wasn't your intention for things. So right now, if I look at our Star Wars data frame, we have a value that, or we have a variable that is called character ID. And the way R is interpreting this is that its data value is a double. So R refers to numeric values as doubles are numeric. But that just means any number, positive, negative, that could have decimal points within it. The other big numeric one would be integer, which we were getting with the with the counts here. So let's say we have this character ID value, and we do not want R to interpret it as a double. We want R to interpret it as a string variable, which it should be. We can use the mutate function to have it go through all the observations in the character ID and change them from doubles to characters. And we can do this in conjunction with a base R function that is called as dot. So there's as dot character, as dot date, as dot numeric, as dot integer, so on and so forth. And this is just ways that you can say, hey, R, I see that you interpreted it this way, but I actually would like it to be interpreted that way. So if I take our SW, so I'm going to overwrite our current one because this is one that I would rather our main data set to be interpreting things correctly. And then we are going to work on the SW underscore DF, and we are going to run the mutate function. And we are going to mutate the variable character ID. And we are going to have that equal as dot character, character ID. So as I mentioned before, we are right now, we have a variable called character ID, but in my mutate, I am calling the new variable I'm creating character ID. So R will look through our data set and it'll say, hey, there is already a variable called character ID. So what I'm going to do is when I run this operation, I'm going to go through and overwrite all of this right here. And then the second line is running the function from base R as character, and it is running it on the character ID variable. So this is what all the output is going to go into, and this is the operation that's going to be run. If I go ahead and run that, and then I look again at my Star Wars data frame, you can see now that the character ID variable is being interpreted as a character or a string variable. It's no longer being um, it is no longer being categorized as a double or a numeric variable. So go ahead and try out the recode with the as character. Um, and if you have any questions, please let me know. And raise your hand when you're ready to move on. Okay, you can go ahead and lower your hand. Thank you. So if I look again back at my at my data set, and I specifically want to look at, we have within the data set a variable that is called gender. And let's say I just want to take a look at what this gender variable looks like. So I'll do Star Wars data frame and I'll subset for I'm just looking at the gender variable. This will show me then, okay, this is what is going on within my gender variables. So let's say right now we have a string or character variable within it. And let's say I want to create a new variable that turn those string variables into numeric variables. So I can do that again with the mutate function in conjunction with the recode function in the argument. So what this is doing is saying create a new variable that's called gender underscore noun, and then recode the current variable gender, where masculine will now equal 0. So every time masculine pops up, it'll get a 0. And every time feminine pops up, give it a 1. And then just so we can see the output, I'm going to also relocate it. I'm going to relocate it. I'm going to actually relocate it before character ID so we can see it. So if I run these lines of code and then I do Star Wars underscore data frame, and then let's also. So every time that it saw gender that was masculine, it gave it a 0. And every time it saw feminine, it gave it a 1. So if you have used SPSS before or just are familiar with working with data, sometimes, especially with categorical variables, it'll have both a data label and then a data value. So this is a way that with R, you can give values to categorical variables or to string variables. Other things that you may want to do then too is rename your variables within your data frame. So as you're working on it, maybe it makes more sense to give it a new name. We can do that with the rename function. So right now this is just called gender, but we have a gender numerical. So maybe we want to go ahead and also have give that gender variable a new name. So we do that with the rename function. And so we'll just rename gender label to equal gender. Let me make sure I get this right because sometimes I always get this backwards. Yeah, that's right. And then gender label will need to put in quotation marks. One nice thing about RStudio, and as you start to work with R coding a lot, sometimes it's knowing when to put around parentheses around something or quotation marks around something. A lot of the time with quotation marks, we're saying, hey, this is supposed to be a string variable, so I want you to understand that before it's saved. One thing you can do if you forget to put the quotation marks is if you highlight what you want to be in quotation marks, if you highlight it and then just do one quotation mark, it will quotation mark the whole thing. Same thing with parentheses. So just a quick little hack for you on that. So if I look at my Star Wars data frame now, we should now have this gender label. The gender variable is now called gender label. Any questions so far? I kind of skipped over the last two. I think recode works the same as if you understand the as character, you can kind of understand the recode. And then renaming is just renaming. It's pretty simple. Next thing we're going to talk about is what to do with missing data within your data frame. So if you are trying to calculate descriptive statistics, so if I want to grab the mean right now of BMI, it's going to give me an NA value. And it's giving me an NA value because if I look in the data frame and I ask it, are there any NA? So this code here is asking within this variable, are there any NA values? And which ones are they? So we can see we do have it. The second you have an NA observation, you can no longer run descriptive statistics on it. So what do we do with NA variables within a data frame then? You have a few options. The first one is the drop NA function, and the drop NA function allows you to drop all missing data from a data frame or a variable, depending on which you say. So what this is going to do is it's going to look through all the Star Wars data frame. And it's going to say if there's a missing variable in any variables in an observation, the whole observation is thrown out. So this removes if an observation has an NA anywhere in the observation, the whole observation is thrown out. So if I notice here, I'm going to go, right now I'm sitting at 87 observations on 14 variables. And if I go ahead and run this, the SW drop NA that I just created throughout 55 observations. So this is a way of bulk removing everything that you have. Now, we could just say this on a particular variable. So if I go into the BMI and I say it, only 7 BMI observations had it. So you can either do this on a whole data frame and say drop the whole data frame, or just within the observation or within the variable. So within the BMI, there were 7 observations that were missing variables. And now if I want to calculate the BMI for it, we can do that. So when I just drop the BMI, we get about a 2.53 mean for it. If I drop the whole data frame, we're going to obviously get a different number. So we're going to get 2.45. That's because it dropped observations, even if so the NA or the BMI observation or BMI lost observations, even if it didn't have an NA in it. So just things to pay attention to as you are working with missing data. More importantly, though, is more importantly, or not more importantly, if you don't want to remove it, if there is a way that you can relabel it, you can also use the replace NA function to relabel a missing data. So what this will do here is it's going to go through the uh, gender label variable. And it's going to say, hey, if you find any missing data in there, replace it as unknown. Because really, if you think about it, we just don't know. So we don't want to remove that observation. The second line is just saying use the for cats. So similar to that as character, what this is doing is it's turning the gender label um, variable into a factor or categorical. So right now I'm asking, So right now it's saying we have masculine and feminine labels. If I go ahead and run the replace option, oh, why do I have this? I might have missed it. I don't think I should have done the mutate first. Didn't fix it. It will though in theory replace it, or not in theory. It does in practice replace it. I shouldn't have done that first step of turning into a factor. I think it threw stuff out within it. Okay. Last thing then is when you are done cleaning it. So one very important thing to know about R when you are using it is R doesn't actually change anything on your computer. So we are playing around right now with a CSV file. We are right now playing around with the CSV file on our computer that is called Star Wars. But right, if you notice right here, nothing has been changed on this file. Nothing has been modified. Last time it was modified was in February. Probably last time I taught the class. Um, so as we are working on something, nothing is actually changing. However, we can tell R to export a file that we've been working on using the write_CSV function. And we do that similar to how we did the read_CSV. We can also do the write_CSV to export. So read_CSV loaded it in, write_CSV sends it out. So we're going to work on so we're going to say here, I want to export the current object, SWDF, and all the changes I made into it. And then I'm going to export it into a new file that is going to be called starwars_clean.csv. So once I run that line of code and I refresh my files, we now have a new file in there that's called starwars_clean. And we could always load that back up then. They'll load it back up. So those are the available data cleaning. My apologies. I have a child apparently that is going through the worst time of his life. I don't know if the microphone is picking that up, but it may have broken my concentration the last 6 minutes. So just to wrap things up, you have available to you a bunch of really not too hard to use functions from Tidyverse that allows you to clean up your data set and get it ready for analysis and all that fun stuff. To run analysis, there are a bunch of packages for it. Then too, if you're thinking about things like ANOVA or linear regression, there will be packages that will allow you to run those on your clean data set. But we also have descriptive statistics that you can just run on it. So your summary, sum, mean, median, SD, min, max are all available to you. My name is Matt Steele. Again, I am a research services librarian here at the university. And I'm always happy to help you as you work on this. Some things that I would highly suggest is to try out things like R for data science and the exercises that they have in there. But if you are currently working on data projects, try out some of these functions on your data project and just see what you can do for it. Next week at the same time, or different Zoom room, but we will be doing how you then visualize your data. And if you are interested in presentation, how you create an R Markdown file. I should say one thing that you also will want to do is as you are working on your R script file is to save it into your working directory so you can always open it up and get right back to it. And then if you're interested in additional data services workshops, we are hosting a bunch of them. We are doing the same series next month as well. So if you are interested in getting another go at these, feel free to get it. I will be sending out the recording once I get it all cleaned up for this session, as well as the slides for this session too, to everybody who's registered for it. So that will probably be Friday, I think, best case scenario, that you should have those by it. And then you should get if you're coming next week, I'll have those slides out too by Friday. Or I'm sorry, the instructions out by Friday. But in the meantime, if there are any questions, I'm happy to stick around and answer any questions you might have. If not, thank you so much for coming, and thank you, Jeff, for helping out.